Gel electrophoresis is a widely used technique for separating and analyzing DNA fragments based on their size and charge. Here's how to perform gel electrophoresis for DNA fragment separation and analysis. Prepare the gel. A. Choose the appropriate type of gel based on the size range of DNA fragments you want to separate. Agarose gels are commonly used for separating large DNA fragments, 100 base pairs to several kilobases, while polyacrylamide gels are used for smaller fragments, 1 to 1,000 base pairs. B. Prepare the gel solution by mixing agarose or acrylamide powder with buffer solution, usually TAE or TBE buffer, and heat until the powder is completely dissolved. C. Pour the gel solution into a gel mold and insert a comb to create wells for loading samples. Allow the gel to solidify. Prepare DNA samples. A. Mix the DNA samples with loading dye, which contains a tracking dye to monitor the progress of the electrophoresis, and a dense agent, e.g., glycerol, to ensure that the samples sink into the wells. B. Heat the DNA samples at 65 to 70 degrees Celsius for a few minutes to denature any secondary structures and ensure uniform distribution of DNA fragments. Load the gel. A. Carefully remove the comb from the gel mold without disturbing the wells. B. Place the gel in an electrophoresis chamber filled with buffer solution, TAE or TBE. C. Fill the wells with the DNA samples using a micropipette, taking care not to puncture the bottom of the wells. Load molecular weight markers in one or more wells to serve as size references. Perform electrophoresis. A. Connect the gel apparatus to a power supply and set the voltage and runtime according to the size of the DNA fragments and the type of gel used. Typically, a voltage of 80 to 120 volts is applied for 30 minutes to several hours. B. Turn on the power supply to start the electrophoresis. DNA fragments will migrate through the gel towards the positive electrode, anode, based on their size and charge. Visualize DNA bands. A. After electrophoresis is complete, turn off the power supply and carefully remove the gel from the electrophoresis chamber. B. Stain the gel with a DNA binding dye such as ethidium bromide or SYBR safe for visualization of DNA bands under UV light. Alternatively, use a gel imaging system for non-UV visualization. C. Document and photograph the gel to record the positions and sizes of DNA bands. Analyze results. A. Compare the migration of DNA bands with molecular weight markers to estimate the sizes of DNA fragments in the samples. B. Analyze the intensity and distribution of DNA bands to evaluate the quantity and quality of DNA in the samples. C. Interpret the results based on experimental objectives, such as genotyping, DNA sequencing, or PCR product analysis. By following these steps, you can perform gel electrophoresis for DNA fragment separation and analysis, allowing for the visualization and characterization of DNA samples based on their size and charge.